Okay, what's up, everybody? Just getting started on a new section here this morning. Don't forget last night's homework on 11.4 is due by the end of today at 5 p.m. The notes you'll take today will be due tomorrow morning, Thursday, before 9:30, before our Zoom session, and then we'll have a quiz over 11.4 and 11.5 on Friday at 9:30 during our Zoom session for that day. Okay, so that's what's happening. Just want to quickly jump into this, get started, hopefully make this video as kind of short as possible, and go from there. Okay, so today we're talking about geometric probability and areas of the sector. So let's think of this rectangle here that we see on our screen. We think of that, let's say that we asked Wyatt to throw a dart at this rectangle. Now, assuming that he could hit the rectangle, which I know is a big assumption, what would be the probability of hitting the red part? What would be the probability of him hitting the red part if he threw a dart at this rectangle? Well, it would be about 50%, right? Because the red part makes up 50% of the total area of this shape. And you can just see that. But what if I didn't just see it? What if I, of course, need to show it on paper? Like, how do I know that? How do I know for sure it'd be 50%? Well, I would just make a ratio of the area of the red part and put that over the area of the whole figure. So in this case, I have the area of the whole figure of 32. And if I figured out the area of the red part to be 16, I could make a ratio of those two things and figure out that he has about a half probability to be about 1 out of every 2 times, or 50%, that he'd hit the red side. Okay, let's take a look at this shape. This is the bottom of page 665. And let's fill in, this is the black things that they filled in, even though they're blue on our screen. It says, what is the probability of this game board of him throwing a dart and hitting the white part? Okay, well, let's just say that that this board is broken up into 6 segments, right? 1, 2, 3, 4, 5, 6 segments on the bottom. 1, 2, 3, 4, 5, 6 segments along the side there. So the whole area of this shape is 36. Now, how do I know what the area of the white part is? Well, if I just kind of extend these lines out through here like this, we can make kind of a grid. And on a very basic level, we could just count the white squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the probability of hitting the white part of this board would be 15 over 36, or we could reduce that to 5/12. If I wanted to make that a percentage, I could just do 5 divided by 12 and say, okay, that's about 42%. So he has about a 42% chance of throwing a dart at this board, the square, and hitting one of the white segments, okay? So I think of this geometric probability as a ratio of the area that I'm trying to hit over the area of the whole thing. Okay, let's say I have it in the shape is a circle, okay? And I'm trying to throw a dart at this circle and hit, let's say, like this top part up here. Well, again, I could look at that circle and say, okay, he has about a 50% chance of hitting the top half of the circle if he were to throw a dart randomly, okay? But how do I figure that out on paper? Well, if I took the area of the whole circle and put that over if I took the area of the small part, the blue part, and put that over the area of the whole circle, I'd get my ratio, just like I did before with the rectangles and the square. All right, so I have to figure out what the area of this sector is, of this circle, this section of the circle. Well, I know just by looking at it, because the diameter goes right through there, that's going to be half. It's half the area of the whole circle. But how did I know that for sure? Well, because if I think of this as being 180 degrees, which it is, sorry about that, then I would just put that so 180 over 360 would give me like the portion of the circle that I'm trying to find, And then if I just multiply that by the entire circle, the area of the entire circle, which we know the formula for that is pi r squared. So now if I knew the radius of this circle, I could find the area of the blue sector. Okay, well, it's just so happens that, well, it doesn't happen, but let's say that this was like 12 diameter, like that. Okay, well, that should make the radius 6. So in this case, I would have that the area of the blue sector would be 18 pi. Okay, so what would be the probability of hitting that sector? Well, if I took that and I put that over the area of the whole circle, which is 6 squared times pi, so 36 pi, that would cancel and I would get basically 1/2 or 50%. So again, the area of the part that I'm trying to hit over the area of the whole thing. How did I find the area of the sector? Well, I took the angle that it made, that 180-degree angle, and I put that over 360. Let's say it only was a quarter of the circle. So that formed a 90-degree angle. So 90 over 360 would be 1/4 if I reduce it down, and multiply that by the area of the circle. Let's say that this radius is 3, so 3 squared is 9. So the area of the whole circle is 9 pi. Multiply that by 1/4 because that is what I'm trying to do, or find what that's what I'm trying to find is the area of the 1/4 of the circle. So that would be like 9 over 4 pi, right? Or if I wanted to multiply that out, I could do it and say, okay, that's 9 times pi divided by 4, and I would get like 7.07. That would be the area of the shaded part, the black part. Well, let's find the probability of hitting that part. What's the area of the whole circle? 9 pi, right? So if I did 9 times pi, I would get 28.27 approximately. So there's my probability of hitting the black part. If I wanted to do that as a percentage, I would just take 7.07, 7.07, and divided that by 28.27. That would give me about, oh, of course it is, it's 25%, right? Because you can obviously see it's 1/4 of the circle. So that's how I'm going to do it. Okay, those were easy because they were easy numbers. 180 and 90, it's 1/2 of a circle, or it's 1/4 of a circle. But what if I have a random number like this where it's 46 degrees? Okay, well, 46, let's figure out what 46 degrees is of the whole circle. So let's do 46 over 360. That will give me like the fraction of the circle this blue part is. And so we're trying to find the area of the blue sector. Well, the radius here is 6 because the diameter is 12 over there. So the area of this blue sector would be the fraction of the circle I'm looking at, 46 over 360, times the radius squared pi, the area of the whole circle. So 36 pi. So what is the area of this sector? Well, let's do 46 times 36 and divide that by 360, and I get 4.6 pi. That is the area of the blue sector. What is the area of the whole circle? Well, we already figured that out. It's 6 squared pi, so 36 pi. So what is the probability of hitting the blue sector? Well, the pi's cancel, so I just do 4.6 divided by 36, and I get, well, that's about 12.7, so let's just say 13%. All right, so that would be what they have in your book as the right answer, 0.13. We didn't want to write it as a decimal, we could say, or if we wanted to write it as a decimal, we could say it's 0.13. Okay, next part. Let's say that I have a circle, but but I have like a regular hexagon drawn inside that circle. And I need to try to find, let's do this better than that. Let's do it like this. Let's say that I wanted to try to find the area of that blue part right there. Okay, what is the area? This is example 3. It says a regular hexagon is inscribed in a circle with a diameter of 14. So change back there. Let's do a diameter of 14. All right. So that's obviously 7. That's obviously 7. So we kind of made a triangle there. All right, well, if I did the same thing that I just did, found the area of the sector, let's make it a different color, let's say red. I could find the area of this entire sector by doing what I just did, right? I need to know what the angle is, the central angle there. It's a regular hexagon. It has 6 central angles. So 360 divided by 6 is 60. So the measure of this angle right in there is 60 degrees. All right, so I'm trying to find the area of this red sector. Well, how did I do that before? I just said, okay, well, 60 is that fraction of the whole circle, so 60 divided by 360. But it's whatever it is, we can just leave it like that. And we'll say, okay, let's find the area of the whole circle and times it by that fraction. So we get the area of the whole circle, the radius is 7, so it's 49 pi. So the area of the sector is 60 times 49 divided by 360. It's about 8.17 pi. I'll simplify it here maybe in a minute, but we know that that's the area of the red sector. Okay, let's mark it so we know that's the area of the sector. All right, now, kind of like yesterday, if I take the whole sector and I just subtract out the area of the triangle. So let's find the area of just the triangle now. And if I take the whole sector and subtract out the triangle, I'll be left with the blue part, which is what I want. So how am I going to find the area of this triangle? Base times height. I just cut that 60-degree angle in half. So that's 30, that's 90, that obviously has to be 60. So I'm back to doing this again, which I did a couple days ago. I would say, okay, what is the area, what's the length of the side opposite the 30-degree angle? It's half of the hypotenuse. And then this side over here would be that time 3.5 root 3. Okay, so let's find the area of this triangle. I'll take the length of the base, which is 3.5 plus 3.57, it's the equilateral triangle. So the area of the triangle is 1/2 the base, which is 7, times the height, which is 3.5 root 5, or sorry, root 3. That's a 3 in there. Okay, so that's the area of the triangle. Let's multiply that out. I get 3.5 times 3.5 is 1. That doesn't make sense. Let's do that again. 3.5 times 3.5 equals 12.25 root 3. All right, so that's the area of the triangle. So let's take the area of the sector, which was 8.17 pi, subtract out the triangle, and I'll be left with the area of the blue part. So I can multiply these things out now. It's probably be the easiest thing. So let's do 8.17 times pi. That gives me 25.67 approximately. Minus, let's multiply that out, 12.25 times the square root of 3. That gives me about 21.2122 rounded. So I've got 25.21 0.67 minus 21.22, and I get 4.45 as the area of my blue section there, okay? What is the probability then of hitting that section? All right, well, I have the area of that blue section. If I took the area of the circle, the whole big figure, and again, put that, my 4.45 over that, I would get the probability. So the area of the whole circle, we already said, was 49 pi. So what's 49 pi? 49 times pi is about 153.94. So let's take that, 153.94, and I could say, okay, if I get that as a decimal, 4.45 divided by 153.94, that's about 0.03 if I rounded, or the 3%. So I would have about a 3% probability, a 3% chance of hitting that shaded area. Okay, so that's pretty much what we would need to know for this section. Listen to that one again if you didn't really follow me, but I just kind of combined some things we've done over the last couple days. Again, probability of hitting a certain part would be the area of the part that I'm trying to hit over the area of the whole entire thing. If I'm trying to find the area of a sector of a circle, I would just take the measure of the angle, measure that angle, and put it over 360, because the whole circle is 360 all the way around. So I would take that and multiply it by the area of the whole circle. That would give me the area of the sector. Then if I was trying to find the probability of hitting that sector or that section of the circle, I would just take the area of that sector. In this case, it was 4.6 pi, put it over the area of the whole circle, which is 36 pi, and I got that to be 0.13 or 13%. So in this one, I did the same thing. I just had to do kind of like a composite figure like we did yesterday. So hopefully it's not too bad. Hopefully you're good. And tomorrow when we meet, you can ask me some questions if you need to, but you'll be able to get right into it. So hope you have a good day today, and we will see you later. And that is all I've got for today. All right, see ya.